All right. If this doesn't get you excited for limits, I don't know what will. Make your hands clap. Here we go. Okay, so we're going to see the dividing out technique in place today. We're going to evaluate one-sided limits, and then we're going to talk about infinity and negative infinity for that matter. So here's our example one. Now we actually looked at this example in the last video. We looked at the graph of it. So we're going to do a different method here. We're going to do the dividing out technique. So here's how we do that. So we're trying to find the limit as x approaches -3. So we're going to factor that top. Okay, the bottom just stays x plus 3. We can put that in parentheses, make it a little safer. So this is just a typical trinomial that we factor. You can do your x puzzle if that helps. But we get x plus 3, x minus 2 up top. Okay, now you can clearly see, hopefully, that these guys take care of each other. Okay, so that's gone. So that leaves you with x minus 2. So now that we have this, we're going to replace the x with -3. So -3 minus 2 gives you -5. And there's your limit. Okay, that's the dividing out technique. All right, here's another one. Okay, so this time we're going to factor the denominator. So that x minus 1 stays put. We'll put that in parentheses. So the denominator is 4 terms, so we're going to factor by grouping. So the first 2 terms have an x squared in common. So if we factor out the x squared, that leaves you with x minus 1. Well, we don't really have anything in common here other than a 1. Okay, so now you see that the x minus 1 is the same. So when you factor out the x minus 1, that leaves you with x squared plus 1. Give me my parentheses there. All right, so again, these guys will take care of each other. So we're left with 1 over x squared plus 1. So now we're going to replace the x with 1. So that's going to be 1 squared plus 1. Well, 1 squared is 1 plus 1 is 2, so you get 1/2. There's your limit. Okay, so that's the dividing out technique. All right, example 3. So this one's a little different. If we plug in 0 for x, that's not going to work, is it? Because remember, you cannot have 0 in the denominator. So we're going to use a rationalizing technique. Now this is actually kind of the reverse of what you might think. Remember, we don't like radicals in the denominator. Well, we need to kind of change that up here. So here's our problem. So we're going to rationalize it. So remember, we change that minus to a plus, and that's how you're going to rationalize it. Okay, so we're going to multiply this to the top, which means we need to multiply that down below. Now up top, you would actually FOIL. Okay, so this times this, this times this, this times this, and this times this. So FOIL, first, outside, inside, last. So up top, when we take this guy times this guy, you're just left with what's inside because the radicals take care of each other. Now your outside, you get positive square root of x plus 1. The inside, you get negative square root of x plus 1. So they cancel each other out. They add up to 0. -1 times 1 is -1. So that's what the numerator turns out to be. Now, down below, we're not actually going to multiply. Okay, we're just going to leave that x times that denominator, and you'll see why here in a second. So up top, we can take the parentheses away. That 1 minus 1 is going to be 0, so you're just left with x. So this is why we did not actually multiply down below, because these guys take care of each other. So you're left with 1 over the square of x plus 1 plus 1. Okay? So now we're going to bring that into here. So this is going to be the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. Okay, so that's what we got bring this back here real quick right there. Okay, so now we can replace the x with 0. So that's going to give us 1 over the square root of 0 plus 1 plus 1. Now 0 plus 1 is 1. The square root of 1 is 1 plus 1 is 2. So you end up with a limit of 1/2. Okay? Okay. Now last video we talked about limits coming from both sides. Now we're going to look at one-sided limits. So you got to kind of look at this guy here. So when that is negative, that means you're coming from the left. What's the limit coming from the left? When this guy is positive, what's the limit coming from the right? Okay, so think of, a normal XY chart, XY coordinate plane, I should say. The minus is over here, the plus is over here. So when this is minus, what's happening as we come from the left? When this is plus, what's happening as we come from the right? Okay? When nothing's there, you're coming from both sides, remember. All right? Okay. So let's find a limit from both sides here. All right, so as we come from, we're still approaching 0, but we're coming from the left. So let's think about that. Let's try -1, for example. 2 times -1 is -2. The absolute value is +2. Divided by -2, you're going to get -2. I think I did that wrong here. Hold on. Yeah. Let me repeat that. If x is -1, I change that down here. 2 times -1 is -2. The absolute value -2 is +2. Divided by -1, you're going to get -2. So you're going to see, you're going to get -2 every single time. All right, so what that means is the left side is going to look like this. Okay? All right, so that's the left side. All right, as you approach from the left, whatever you plug in for x, you're going to get -2. Okay? So as we approach 0 from the left side, your limit is -2. Now let's approach from the right side. Okay, we're coming from this side. Let's start with 1. 2 times 1 is 2. Absolute value of 2 is 2. Divided by 1 is 2. So you're going to end up with +2 every time coming from this side. So what's going to happen is it's going to look like this. Okay? No matter what you put in there, if you put in 5, 4, 3, you're going to end up with 2. So as x approaches 0 from the left side, your limit is -2. As x approaches 0 from the right side, your limit is +2. Now, what if, and this is from the last video, what if we had the limit as x approaches 0? Okay. So we learned this last video. What do you think happens? So as x approaches 0 from the left side, your limit's -2. As x approaches 0 from the right side, your limit's +2. What if x approaches 0 from both sides? See how they don't meet? So in this case, the limit does not exist. But again, as you can see, if we approach just from one side, it does exist. Okay? All right. Example 5. Okay, so we want to find a limit as x approaches 1. Okay, so we're going to look at this, two different ways. From the left side, from the right side. So here's where x is less than 1. Here's where x is greater than 1. So what is the limit as x approaches 1 from the left side of this function? Okay. And then we're going to find the limit as x approaches 1 from the right side of this function. All right, so on the left side, we have 4 minus x. Well, that's just a straight line. Kind of go off here, but it's going to look something like this. Okay, so from the left side, as x approaches 1, what's our limit? 3. Okay, so that's the left side. Now, if we graph this, when x is greater than 1, it's a quadratic, it flips, okay? It's going to end up looking like this. So it's going to look something like this. So that's this guy here when x is greater than 1. Now, as x approaches 1 from the right side, where do we approach? The answer is 3. Okay? So from both sides on this one, we approach 3 as x approaches 1. All right? So because of that, because the one-side limits both exist and are equal to 3, the limit as x simply approaches 1 is 3. Okay? All right. Definition of limits at infinity. So as x approaches negative infinity, okay, we get a limit as x approaches positive infinity. All right? So this is, you know, it's going to make sense here once we do some examples here, hopefully. But before we do that, do you guys remember Bobo, Botan, and the other? So we did this in Algebra 2, talking about asymptotes. Okay, so Bobo means bigger on the bottom. So see the exponents? See how this guy is bigger on the bottom? We ended up with an asymptote of 0. Okay, well in this case, that's going to be our limit. So if it's bigger on the bottom, your limit is 0. BOTN, Botan, bigger on top, nothing. So here's your 3, here's a 1. See how we're bigger on top? Nothing. So your limit does not exist. And then the other, what happens when they're the same, what you do is you do the dividing technique. So 5 divided by 10, and you get 1/2. So this would be your limit in those scenarios. All right. So example 6. We want to find the limit as x approaches infinity. Now, we can actually separate this. Like such. All right, so we got the limit as x approaches infinity of 4 minus the limit as x approaches infinity of 3 over x squared. Now, this one's just going to be 4. Okay, the limit as x approaches infinity, you just get 4, that's it. Now here, think of your Bobo, Botan, or the other. This is a Bobo scenario because we're bigger on the bottom. There's no exponent on top. So the limit for all of this is 0 because it's a Bobo scenario. Bigger on bottom. Okay, and then 4 minus 0 is 4. So there's your limit. So that's how you deal with infinity. Okay, so these are actually pretty quick once you get the hang of it. Just look at your variables and your exponents. So see how we have that. So this is a Bobo scenario. So your limit is 0. Okay, now these guys are the same. So this is the other. So we got to divide, -2 divided by 3. There's your limit. And this is a Botan scenario because we're bigger on top. Look at your exponents, bigger on top. Bigger on top means nothing, so this does not exist. Okay, so that's all she wrote there. All right, that concludes Unit 13, Day 4. Here's our question of the day. A man leaves home and turns left 3 times, only to return home facing two men wearing masks. Who are those two men? All right, good luck on that. And that's it, okay? Go Cougars.